This is a basic circuit diagram of an NMOS MOSFET. It has 4 different terminals: the gate, the drain, the source, and the bulk. Generally, the bulk and the source are connected together, and whichever terminal is based at a higher potential is called the drain, the other is called the source. Typically, the source and the bulk for NMOS MOSFETs are both grounded. This is the NMOS's physical structure. As you can see, it has a P-type substrate, which is generally P-type silicon, and then 2 heavily doped N-type terminals to which the current or charge carriers are to flow. Since we want this MOSFET to be as close to a switch as possible, we want all the current flowing in the source to be able to flow across and flow out of the drain. But as you can see here, this P-type substrate creates a barrier between these 2 N-type terminals. That's what the gate terminal is for. This gate terminal is essentially connected to an electrode. When you have a high gate voltage, if you apply a high gate voltage, that will essentially push all these positive ions that are in a P-type substrate, and they will repel them away from the channel. When that occurs, it will generate a channel of negatively charged ions that will create a path for the current that enters the source to flow across to the drain. So when this channel is formed, you then apply another positive voltage at the source that will then push these ions across into the drain and out. If you apply a gate voltage lower than the source, then the NMOS will not create a channel, or essentially will not turn on, because the current has no path to flow in. This is a very simple illustration of it. We need to create a path for the ions from the source to move into the drain. But initially, this P-type substrate creates a barrier. So we need to apply a voltage at this gate so this barrier or this path can be pulled down so that these charge carriers can flow across. So when this voltage is applied, now these negatively charged carriers have a path to move. So when I apply a voltage here, it has enough energy to push this current across there. And that's essentially how the MOSFET works. When the gate voltage is lower than the source, then these carriers have no way to flow across the channel.